So we're starting in chapter 7. We're going to do today 7.1, 7.2 combined. Yeah, so we're definitely doing some super mathematics to do all this in this short period. No, this is really what we're going to talk about is systems of equations. These first few lessons, things that we've seen before. I know you've done systems of equations basically since you've learned algebra. So today is going to be just kind of a really quick hitting the high points of systems of equations. So today we're only going to talk about systems of two equations, but I just wanted to talk about a little terminology first. When we talk about a system of equations, we're talking about two or more equations with the same variables. For the most part, what we're going to do is talk about linear equations. So we call this a system of equations, and our solution, if we're talking about a system of two equations, a solution is an ordered pair so we get an x and a y if that's our variables, x, y, that makes both equations true at the same time. So we're going to say x, y, and we're going to say that satisfies both equations. And I said two or more, so we're going to say satisfies all equations. So I said both because today we're just going to be talking about sets of two equations. So when we have a system of equations, we have to get a set of solutions that's going to satisfy all the equations. It's going to make them all true at the same time. So the first method of solution we're going to talk about a substitution. We've used substitution for various things over the course of the semester. We use substitution on the last test. That's the problem with the tension. We use the substitution to solve that. So substitution means you solve one equation for one of the variables, and then you would substitute that into the other equation. So I just want to set up an example. I'm not going to go through the entire thing, but once we see it, we understand. We should understand what we mean. So if we have something like x plus y equals 5, and x minus y equals 3, and this is our system of equations. We use one brace here to show that we have a system of equations. When we do substitution, we would solve one equation for one variable. So I'm going to say for this one, x equals y plus 3. And then I take that value of x and substitute it into the other equation. And that lets me solve for y. Once I have y, I can plug y into either one of the equations and figure out x. So something that we've done a number of times this semester, something that you've done before in other classes. Well, first off, if we graph these two equations, what would the graph of these two equations be? What would the graph of x plus y equals 5 be? a line. So these are graphs of lines. So these are linear equations. We can use substitution on equations that are not linear, sometimes. So if we had something like x squared plus y squared equals 5, and we had another equation, x plus y equals 1, and that was our system of equations, we can use substitution here also. Anybody know what the equation of x squared plus y squared equals 5 is? That's a circle. So this is going to be a circle and this is going to be a line. So that's what this is. But we can use substitution here. So I can solve this one for either x or y. So I could say x equals 1 minus y. I substitute that into the other equation. I get 1 minus y squared plus y squared equals 5. We know how to solve these kinds of equations. I would FOIL this out. I would get something y squared plus something y plus some other number equals 5. Then we get everything on one side so it equals 0. In either factor, we use a quadratic formula. So this is another type of equation that we have experience solving. We've spent a lot of time in Chapter 2 solving equations like this. So we could use the method of substitution to solve an equation, a system of equations like this, where we don't necessarily have a linear equation, or a set of linear equations. So this substitution method does work in these kinds of equations. And anytime we're solving systems of equations, we can always check our work. When we're done, when we get our answer, plug your numbers back into your equation, make sure they work. If they don't work, you've done something wrong. So you can always tell if you've done your problem correctly or not. So there's our substitution method. Nothing new, nothing unusual, nothing that we haven't seen before. Questions before we move on? Okay. What's another method that we've used this semester for solving two equations at once? Elimination is one. We'll talk about that in just a second. We've used another one also. Our favorite math tool, our calculator. What can we do in our calculator? Graph. We graph our two equations, find where they intersect. We did that quite a bit in Chapter 4 when we talked about trigonometry. We graphed our trig equations and found where they intersected. So we can also solve systems by graphing. When we can use our calculator to graph, that gives us a nice, quick, easy way to solve systems of equations. And they can be very complicated equations, like we saw when we were doing trigonometry. We could put complicated trig equations in there and find the solutions to these equations. So when we use graphing to solve systems of equations, we want both equations in y equals form. So in order to put them in our calculator, we have to have y equals something. So both in y equals form, put them in our calculator, and we graph and find where they intersect. So graphing is a nice way when we can use it, and especially when we have complicated functions. We can use our calculator, find where they intersect. Again, something that we know how to do, something that we've done before. So solving by graphing. That's our third technique. And then Justin said we can also use elimination. Solving by elimination. We tend not to use that one as much, but it is a nice tool. So when we solve by elimination, what we want to do is if we have two equations, that's what we're talking about today, is two equations. We multiply one or both equations. Multiply one or both equations. You guys scared her away. One or both equations by a number. So that when we add them together, one of the variables goes away. And I guess rather than goes away, you could use the word is eliminated. And that's why we call it elimination. So let's look at a couple of examples when we're talking about elimination. So let's say we have 2x minus 3y equals 7. These are pretty easy examples. And 5x plus 3y equals 0. Usually when you solve systems of equations, and what we'll end up doing, if you're not using substitution, you want to get the x's and y's on one side and the number on the other side. We could solve this by substitution. Substitution always works. So we could solve one of these for x or y. But what could we want to multiply one or both of these by a number so that when we add them together, one of the variables goes away. So what do we need to multiply by? We don't have to multiply at all, right? Because we have a negative 3y and a positive 3y. So I add those two together, add those two equations together, and I get 7x equals 7 when I add these two equations together. And that tells me x equals 1. And then I can plug x back into either of these equations and solve for y. So I'm not going to go through the process of solving for y. We can plug that into either equation and solve for y. And then we would check our answers. Make sure that we got the right answers. So let's look at an example where we do have to do a little more work. So let's say we have 2x minus 3y equals negative 15. And 5x plus 2y equals 10. And that's our system of equations. So we want to use the method of elimination. So what are we going to multiply? How are we going to work with these equations to get one of the variables to go away? What do you think, Julie? Okay, so let's multiply this one by 2 and that one by 3. And that would make the y variables go away. So let's write that out. So I get 4x minus 6y equals negative 30, and 15x plus 6y equals positive 30. This one works out really nicely. Add these two together. So I get 19x equals 0. Divide by 19, so x equals 0. You can plug that into either one of these equations. So I'll plug x equals 0 into the bottom equation. So I get 5 times 0 plus 2y equals 10. So y equals 5. And my solution is the 0.05. And if I plug that into either one of these equations, it all works out fine. So that would be my solution. So elimination is nice when you can use it. It's sometimes easier than solving one of these for x X or Y. We can always use substitution. Elimination sometimes can work out nice and clean. So three methods for solving these systems of equations. So questions on our techniques here. All right, just a couple more quick things I want to talk about. I want to talk about what these equations mean graphically. What are we looking at? So I'm going to say the graphical interpretation. We have three possibilities. When we're talking about, so right now I'm talking about graphing two linear equations. So we have three possibilities. So here are my axes. My first possibility is if I graph my two lines, I'll graph those in red. And they intersect in exactly one point. So there's my solution. This is what we look at what we're looking for when we look for a graphic, when we're using graphing to solve. So we could have exactly one solution. So our lines intersect in a point. In, at, on, I don't know which thing to use. Lines intersect in a point. There's another possibility that I could have something like this. The lines are parallel. How many solutions would I get if the lines are parallel? None. No solution. How do we know if we're using substitution or elimination, how would we know that we have no solution? What kind of answer would we come up with? Well, we could end up dividing by 0. What normally happens is you come up with something like 0 equals 1, 2 equals 5. Something that's impossible. This would tell us no solution. Because 0 never equals 1, 2 never equals 5. So anytime you come up with something like this, that tells you that your lines are parallel. There are no solutions. And if you found the slopes of both of those lines, the slopes would be the same. And our third possibility, what would be our third possibility? They're the exact same line. So I'm going to draw that one like this and like this with the arrows. So we see there's two arrows, two lines there. So both lines are the same. So we really only have one line. How many solutions do we get here? Infinite number of solutions. Any point that's on that line is going to be a solution to that system of equations because they're both really only one line. When we use substitution or elimination, how do we know we have an infinite number of solutions? What does our answer look like? 0 equals 0. Or we could end up with something like 1 equals 1, 10 equals 10. So we get something that's true all the time. So these are always true. 0 is always equal to 0, 1 is always equal to 1. So any answer like this is going to tell us we have actually only one line, and we have an infinite number of solutions. So these are our three possibilities when we're talking about systems of equations, and we're talking about two lines in the plane. On Monday we'll talk about systems with three variables, and then our possibilities are planes intersecting, and there are a few more possibilities for that. So questions on what we're looking at when we look at these graphs and what they tell us. Again, nothing here should be surprising or anything that we haven't seen before. All right, I want to set up one particular kind of application problem. I just want to show you how to set it up, because they can be setting this type of equation up can be a little difficult. So I just want to show you how to set up. We're not going to go through the whole process of solving. Once we set it up, we'll see how to solve it. So let's say we have $10,000 to invest in two funds. One pays 8%, and we're talking about simple interest. We're not doing any compound interest yet. And one pays 6%. And the question that we want to answer is, how much do we put in each? To earn $720. All right, so this is our problem. So we need to set this up. So let's say that X is our amount in the 8% fund, and Y is the amount in the 6% fund. So how are we going to set this up? Well, the total amount of money we have is $10,000. So how can we write an equation for that? X plus Y equals $10,000. And this is simple interest. So how much interest do we get from the 8% account? 0.08 times however much money we have in there. And we're going to add that to the interest we get from the 6% account, 0.06 times Y. And we want that to equal $720. So there's our system of equations. So once we've written it out, solving it shouldn't be that difficult. Looking at this, what would be a good first step to use to solve this equation? So we could solve this one, put this into the bottom. What would simplify our work a little bit before we even do that? Multiply the bottom by 100 to get rid of those decimals. So I could say X plus Y equals 10,000, and 8X plus 6Y equals 72000. So that would get rid of those decimals and make it maybe a little easier to work with. We wouldn't have to. We could jump straight in and do what Emily said. That would work. And then we could use substitution or elimination. Substitution would probably be pretty easy here and solve. Any questions there? Painless review of solving systems of two equations and two variables? All right. Homework. There you go.